One of the techniques used to graph logarithms is to use graphing transformations of the kind that we've done before with shifts and stretches and shrinks and reflections, and talk about how those work with logarithms. So if you have your parent function logarithm, and what I've done here is I've drawn the parent function that I want to use. It's f of x equals log base 2 of x. If you know what your parent function looks like, you can kind of work through what's going to happen in this transformed function right here that I have shown here, g of x. Okay, so let's take a look at what these functions appear like on the graph. F of x equals log base 2 of x. Well, that's going to be something similar to, let's see what I've drawn before here. It starts out really close to the y-axis and then basically bends up and over. So that might be f of x, your parent function. Well, let's look at the red function here and see what's happening. And before I commit to drawing a graph, let's try to write down in words what we're seeing here. That right there is a shift, right? It's plus or minus a number, and it's inside the parentheses, so that means it is a horizontal shift. Horizontal shift. And which direction is it going in? Well, it's -1. And if you remember, everything is weird when you're in the x direction, so -1 is actually, no. See, it's weird. -1 is actually to the right. You'd expect it goes to the left because that's where negatives are. So this is a horizontal shift right by 1. And what else is happening? Well, we've got this -3, but that's outside the parentheses. And when you're outside the parentheses, you're vertical. Okay, so the question is which direction? Well, up and down is normal. That's what we would expect. Negatives go down. So this is a vertical shift down. Okay, so let's see what the effects are on the graph. There's nothing else going on, reflections or stretches, so I'm just going to go ahead and draw the shifts. And I want a shift that goes right by 1, down by 3. So maybe we have a point that starts here, goes over by 1, down by 3, something like that. So here's our graphed function. It's going to be over by 1 and down by 3, something like that. It's not a great picture. The important part when you're drawing these exponentials is you really need to get that asymptote correct. Okay, so whereas the asymptote used to be at x equals 0 in the parent function, now it's at x equals 1. That was the horizontal shift right. Okay, so let's do another example. In this one, and again, I'll just get my parent function on here. It's log base 2 to the log base 2 of x again. And what's happening in this transformation? It looks like I've got several things going on. There is this vertical reflection that you can see in that negative sign. And what else do we have here? That is another horizontal shift. And once again, that's a -1. That means right. And this time, there's a +3. So that is a vertical shift. And this time it's going to be up. Okay, so if we try to draw these things in order, remember you always do reflections before you do shifts. So if I were to draw this one step at a time, which might make it easier, here's my vertical reflection. Okay, it's basically a mirror image of this graph flipped upside down. And then what I'm going to do is shift it to the right 1 and up 3. So whatever this point is right here, it's going to go over 1 and up 3. It's going to be somewhere around here. And you might have a graph that looks like this. Okay, so we can clean this up a little bit. Oh, that's too much, but what's done is done. Let's see. Remember what the important part is when you're graphing logarithms. Just get that asymptote right. Okay, so this asymptote is x equals, well, it was meant to be x equals 1. I know it doesn't look like that, just bear with me. So the asymptote is going to be at x equals 1. Let's try to get where our axis was. And you can see this graph has been flipped upside down. Now it's dropping instead of rising. And it's gone over to the right and up from the original. Okay? So one more time. And I'll be honest, it's hard to graph logarithms by transformations, but sometimes it's useful when you're trying to figure out what transformations happen in a graph that you're looking at, and you're trying to go backwards and figuring out the equation. So in this one, we'll put the logarithm graph on here again. This is log base 2 of x. Okay, that's our parent function. And this one, I want a little more room here. So let's not mess everything up all at once. There we go. Let's take these transformations one at a time. So what's going on here? This equation is kind of hard to parse out because look at this. It's -1 minus x. And if you remember, this was one of the trickier situations where it seems like we might have both a reflection and a shift going on horizontally, which is trouble. So let's try factoring out. See that negative sign on this x? Let's factor out that negative sign and see what happens. Log base 2, that's not changing. And then I factor out the negative, and what's left? You basically have an x plus 1 inside the parentheses. Okay, and you still have this -3 outside the parentheses. And if you don't believe me, or if you don't see it yet, just look at what happens when you distribute this negative sign. That makes a negative x, and this part right here makes a -1. So you have your original form back. I've just changed the way we write it. And the reason it's better in this form right here is you can see we've got a negative, or a horizontal reflection going on with that negative sign. And you can also see that +1 right there. That shift is a +1. That means it's a horizontal shift left. Whereas in the original equation over here, see that -1? It might have seemed like this was going to go to the right again, but this one is actually going to the left because not only has this thing flipped side to side, left to right on the x, but it's also flipped the shift side to side. And then at the very end, we have a vertical shift down by 3. Okay, that's this 3 right there. And I don't know why. Okay. So let's try to put these things together into a graph. I've got a horizontal reflection going on. So what's that going to look like? That is this weird thing where I just flip it left to right. So maybe it looks like this. And now it's going to shift left and shift down. So the shift left by 1, that's going to, you know what, for once, let's try to do this smart. And I'm going to draw my asymptote first instead of the other way around. So now the asymptote's on the left, and it's been shifted left by 1, and that means your function is going to start like this. And it's been shifted down also, so it's probably going to bend over sooner. And there you go. This is an approximation of what's going on with these 3 transformations right here.